Okay, let's start our session. So far, we talked about the solution and how to solve different type of question by reviewing homeworks and some example session. We are gonna continue on homework 2. We didn't able to go over the last question, the question number 9. So we are gonna cover that today and answer some questions. So we are gonna make sure that you're all clear on the concept and how to solve the questions for the midterm exam. Okay, the question number 9, as you could see on the board, says that in a game between two equal teams, the home team wins with a probability of p, lowercase p, which is a number more than half, 1 over 2. In the best of 3 playoff series, a team with the home advantage has a game at home, followed by a game away, followed by a game at home if necessary. The series is over as soon as one team wins twice. Okay? Now, what is the probability of H, which we defined H as the probability that the team with the home advantage, okay, wins the series? So, first question. There are two teams. One have a home advantage. They are going to play. The team with the home advantage have the probability of P to win the game. The next game is going to be away, and if necessary, there's going to be the third game at home for that team. And by if necessary, we mean following the condition that whenever a team wins twice, the series is over and the competition are decided. Okay, so if the first team, the home advantage team, wins the two first game, there is not going to be any third game. Okay, so that's the if necessary means. Now, this is a sequence of, again, tests. And our first step when we're dealing with the sequential probability was a tree diagram. Remember that? So we start with tree diagram. The home advantage team had two possible outcome out of the first game. Either win it or lose it. Okay? The probability of winning based on the question is P, and ergo, based on the axiom that we learned, the probability of losing the game is 1 minus P. Now, in the second game, the other team have a home advantage. Correct? So the possible outcome of the second game is going to be the first team win or lose. Okay? But here, because the other team has a home advantage, winning for the first team is going to be 1 minus P. Is that clear how we decide that? In the second sequence, our desired team doesn't have home advantage. The other team has. So the winning for the other team, which means losing for our team, have a probability of P, and the complement of it is 1 minus P, which is winning of our team. So we have two options for each of the possible outcome of the first test. And for the third game, since the condition is that team with the two wins would basically wins the competition and the competition is over, the branch of W1, W2 would not have any possible branches on the third game, okay? Because it's already, we have two wins and the competition is over. Same goes with the L1, L2. If our team loses twice, meaning the other team wins twice, so the competition is over. There is not going to be a third game. But the other point, the other possibilities would branch out for the third game. And in third game, again, our desired team have a home advantage. So the winning has a probability of P and the losing 1 minus P. Now that we have our tree diagram, we could have the sample space of our competition. Okay, the sample space is either W1, W2, W1, L2, W3, W1, L2, L3, and as you could see, the other 3 elements. So we have 6 elements in our sample space. And the probability of each element, because it's sequential and independent, is going to be the multiplication of all the events that happen in a row. So for the W1, W2, we have P multiplied by 1 minus P. For the other one, we have P multiplied by P multiplied by P. So it's PQ. The third one is P 1 minus P. So it's P squared multiplied by 1 minus P. And we could kind of like calculate the probability of other elements in the same way too. Okay, so now we have the probability of each possible outcome for this game. Now, the question asks us that what is the probability that the team with the home advantage win the series? For winning the series, the team with the home advantage should have 2 wins. So it would be, we have to choose the elements within sample space. Either is the first element, W1, W2, or the second element, W1, L2, W3, or the fourth element, which is L1, W2, W3. Either one of these conditions, these elements, would result to the win of home advantage team. So, because either one of them could happen, there is an or situation between them, you have to add the probability of each element to each other. So you have the probability of event H, which is winning of the home advantage team. Make sense? Are we clear? So if you do that, you would find out that the summation of the probability would be equal to P over 1 minus P, PQ plus P multiplied by 1 minus P squared. Now, the second question asks us, is the home advantage increased by playing a 3-game series rather than 1-game playoff, or it's the other way around? So our home advantage team have a better chance. Which one is the better chance for our home advantage team? Having a 3 games competition or only 1 game? Okay, competition. How we could decide that? We know that the probability of winning in a 3-game competition, we already calculated that. This is this formula, okay? Based on the P, which is the probability of winning. For 1 play, for the home advantage game, we know that the probability of win is P itself for 1 game with the home advantage. Okay? So we wanted to see which one, considering knowing that the P is a number, does it have equal or no? Bigger than half, which of these 2 conditions would give the home advantage team higher chance of winning? So it have higher probability. How we could decide that? Okay, There are a few ways to calculate that. First of all, we have to calculate this function based on the p. Okay, we have to like simplify that function. If you simplify that function, let's do that. This is gonna be p plus p squared plus p cubed plus p minus p cubed, correct? So the p cubes are canceling each other. Is that correct? Yeah. What did I did? Okay, let me do it again. I'm kind of like got confused in the middle of that. So this one is p minus p squared plus p cubed plus p minus p squared, right? So it's gonna be p. Oh, yeah. Now I see what I'm doing wrong. Thank you. It's gonna p minus 2p square plus p cubed, right? Now I think it's correct. Are we good? Yeah, okay. So it's gonna be 2p cubed minus 3p squared. And so we cancel these plus, oh, come on. See, this is the perks of okay. Oh, come on, I have to do that again. P minus p squared plus p cubed plus p minus 2p squared plus p cubed, which is 2p cubed minus 3p squared plus 2p. Am I good? Is okay, make sure I didn't make any mistake. I'm just doing it right now. Okay, so now we have this function, okay, and we wanted to decide if it's gonna be bigger than p itself, considering we have the p a number between half, bigger than half is not equal to half, between half and 1. Okay, so p is gonna be between half and 1. Okay, now which one in this interval, which one of these two functions are bigger? We have several ways to do that. One is doing the mathematical way, like p is a fraction, is a less than a 1, so p squared is less than p and p cubed is less than p squared. So you could kind of like use the arithmetic summation of these numbers with each other and try to find the connection, the relation between the probability of 3 games winning and probability of 1 game winning to see which one is bigger. This is one way to do that. but it's a little bit harder. The easier way is to use the function and actually like draw the functions. Okay, if you draw this function as a continuous variable, you would find that you could draw that with any kind of like software or with hand, and you find that within the interval of half and 1, the value of this function, okay, is gonna be lower than the value of this PQ. Another way is to put actual number. You know, P is a number between half and 1. You could put like 0.6 as a P and see which one is bigger. And try 0.7 as a, P and see which one is bigger. If you do that, you would find that having a 3 game actually decreases the chance of winning for the home advantage team. So 1 game would have a better chance than 3 games. Are we clear how we did that combination? So we need to calculate each of the 2 combinations, and within the interval of probability that we have, we compare them. If you compare them, you could cancel out a P from each of these equations. So it's going to be 2P squared minus 3P plus 2. And the other side of this relation is going to be 1. You could move around the 1 point, okay, from one side to another. So this is going to be 1 and 0. So if this value, which is this function, is positive, meaning that the 3 game probability is bigger than 1 game probability. If it's equal to 0, means the 2 have the same probability. If it's lower, is negative, this function is negative, which happens here, means that the probability of 3 game is less than probability of 1 game. Is that clear how we reach that conclusion? Any question about that? Are we good? Okay, let me see if okay, it's the continuous of the same kind of question. That is it true that P of H is bigger than P for all the P more than 1/2? Which, if we do that, we would see, no, it's not. It's only equal in the point P equal to 1/2 and P equal to 1. In between those numbers, if you run the analysis, you would see that the P of H is less than a lowercase p, the value. Are we clear so far? Okay. So this is the homework solution. If you have any question, let me know. Otherwise, I think we are good for this session. We could finish this session, and you could have like more time to go over the concept. And if you have any question, please email me as soon as possible. Do not postpone that to the night before the exam, okay? So I could answer you. And I'm gonna see you on Monday, 4 p.m., same location, and we would have our first attempt for the midterm, okay? Any question? If you didn't mark your attendance, please make sure to do that. The attendance sheet is here. Thank you.